Good morning, everyone. I would like to introduce first our speaker, Dr. Soumyadeep. And Dr. Soumyadeep is a senior software engineer developer, KPIT Technologies. And Dr. Ray has been working in the commercial vehicle sector and conventional powertrain development sector. Dr. Ray has been working in the field of power electronics, electric vehicles, and also the applications in renewable energy for many years, and is the author of many reputed international journals and conferences. After having an academic career in NIT Jaipur and RK University, he is now working on electrical and software architecture design of electric powertrains and also the electronic control unit, model-based design of vehicle control, and also state flow of vehicle movement, traction motor control, design of test rig development for individual component level testing and for integrated system design, including battery management system, charger and motor controller, and other related domains. So I welcome sir, and I'm sure that our audience will gain enough knowledge from sir's presentation. So I think, okay. Sir, if you can just share your presentation.
Yeah, I think I cannot share while other participant is sharing. I think you have to stop sharing the screen.
Okay, so IT team, can you please help? I think.
Hey, Bedadri, I think you have shared this poster, so you have to remove it.
No, I think Viral sir.
I am just stop sharing. So now you can share, sir.
Yeah. Now I can. I think visible, right?
Yeah.
Yes, sir.
Okay, fine. So should we wait for another 5 minutes or should we start?
I think we are live, so we should start.
Yes, sir.
Okay. Then good morning, very good morning to every faculty members, students, and other colleagues whoever present in this webinar, or I can say that. So today I will give you a brief demonstration actually how the industry works on the field of electric vehicle. So how the development process actually takes place in the industry, so that whoever is working or whoever is eager to join in the electric vehicle industry in upcoming days, or whoever are interested for the startups for electric vehicle companies, so they will be very much enthusiastic about this topic, and they will learn something about business, something about the technical aspects, and the typical technical as well as hardware and software aspects which you need to be followed with the coming days. So those are my topics which I'll try to touch in another 1 hour. So some of my slides I have already presented, so some of the slides might be repeating, but it is required. That's why I have kept all these basic slides, because I think faculty members and students from other department apart from electrical engineering will be also present in this webinar. So I am just starting. Just give me 1 minute. Yeah, so I'm just starting. So this is basically most of the figures I have taken from internet. Some of that images I have kept within myself. So do not use without any kind of my permission. So that would be a copyright case. So that is a request. So I'll start. So basically, first we'll go through the history. So if you see the history, in the year of 1831, basically electric motor was invented. Then definitely some scientists, they have worked on the electric vehicle in the year of 1832. So it is not the new technology. Everybody is talking about EV, but EV is not the new technology, or it is not any rocket science kind of technology. It has been existed in our society for before 200 years almost. So what is the meaning of this? So definitely there were some challenges which could not be solved at that time span of the century, because of the equipments were not there, that much, resource were not present or such like that. So slowly and steadily, yeah, research progresses. And at that time, the diesel vehicles, petrol vehicles, IC engines basically take over the market. And till today, they are running smooth operation wise. If I am saying operation wise means if you see the working principle of the IC engine, they are quite smooth and quite okay with everybody. So no customer complaint, I can say, in that point. So what is the need basically which drives the electric vehicle revolution in the year of 2000, this era basically 2000, after 2010? So what is this basic thing happened in between? So one is that the fossil fuel, that nowadays petrol price and diesel price all are being hiked by the government for obvious reasons, and it is going to be much more larger in upcoming years. So it is the obvious one of the challenges everybody has to encounter. So this is one of the agenda from where the electric vehicle comes into picture. But what happens to the science? So in the science, basically there are two verticals, or I can say one vertical, that is called battery technology. One is called battery technology, another is called the electric drivetrain. Drivetrain means the motor control unit, or you can say the traction unit. So these are the two major areas where the research happens in past few years, and we have very good understanding of that area. The people from chemistry background, people from electrical background, people from electronics background, they all came together and developed much more efficient battery packs. So whenever you are creating some battery packs, it is not like that you just create a battery pack, it is ready to use. As I think I'll give a recent example. So you all have heard that the Ola electric bike battery explodes or something. So everybody is checking that no, EV is not the suitable option for right now. It is not. It is not the same thing. So you have to understand the technical perspective. As you all are engineers, even faculty members, maybe somebody knows these things, or you are aware of these things. But for the sake of student, I want to tell you that there are two things. One is battery, another one is that one software will be there, which software basically ensures the safety of the battery. Means if something happens inside the battery, it is the responsibility of the software which will ensure the safety of the passenger. Okay, so there are two different things. One is the battery technology itself. Another one is that the software which basically ensures the safety of the battery system. So battery technology is obviously one thing. Whoever is developing the battery, so you need to go through a lot of test cycle to prove the efficiency of the battery, to prove that its life is very much good with the with operation. Because if you want to change the battery with 1 year or 2 years, it is not as cost effective, you can say. So battery should be long lasting. That is the one major thing you have to go through. And third thing, obviously the chemistry nowadays, LTO chemistry and lithium ion chemistry, this much more chemistries are present. So what they are doing, actually, they are developing much higher energy density inside a cell of the battery. So for that reason, what is happening, the size of the battery or sizing of the battery, that becomes reduces. Basically, if you want, suppose 5 kilowatt of power, previously it was that much size, and now today it is having this much size, but again it is able to delivering the same amount of power. So what happens, basically space was the constraint whenever you are designing some cars or some vehicle. So space you have to use optimally. So in case of optimal use of the space, the battery size is reduces, as well as the efficiency is there. Another thing is that there is one thing called C rate of the battery. So C rate of the battery, so basically whenever it is charging, it should be capable to take, higher C rate. C rate basically is related to the current. So whoever don't know, so I am just telling you the basic things. So basically it is able to take much more current than its rated capacity. So suppose 1C is 40 ampere, means battery is able to take 40 ampere of current whenever it is charging by any medium. Let it be it is fast charger, let it be your slow charger, any charger, but battery should be able to take 40 ampere of current. If the battery is rated 40 ampere itself, then it is called 1C of the battery. But if the battery is able to take 80 ampere, then we call it, okay, battery is able to take 2C rated thing. So now if we charge the battery with 120 ampere, battery is able to take 120 ampere, means 3C rate. So what happens? I am telling you two things. One is slow charger, one is fast charger. If the battery is able to take 40 ampere only, means it might take 8 ampere. It is an example. Don't take it otherwise. It is an example only. It is not the absolute value. So suppose we take it that it is a 40 ampere it can take, and 1C rate, it get fully charged from 0% of SOC to 100% of SOC for 8 hours. It will take 8 hours long. But if you charge it to 80 ampere, then what is happening? It will take half of the time. So at that time it will take 4 hours. If you increase the capacity up to 4C, then what will happen? The battery is the same battery, it will take 2 hours of time. Okay, so basically it is, time reduces. So time reduces with the battery technology. So charging will be much more faster. So what is the means? Basically, there are two things. One is battery technology. So battery technology helps us to charge the vehicle faster. So basically, your stop time in between charging, that is the one of the major areas of concern of research that basically takes care by this kind of technology of the battery. Okay, then you can say, okay, so can I pump that much battery in my mobile battery also? Then my mobile may charge in 1 minute or 2 minutes. But there is a issue of your chemistry, as well as there is a issue for your cooling purpose or your cooling circuit. So battery need to be properly cooled. So in the vehicle, it might be air cooled, it might be you liquid cooled. One of the major problems in Ola battery, what I have read, actually it is air cooled, because it is a two-wheeler bike. So they don't have the space, or they don't have the technology with liquid cooling. So battery should have liquid cooling as per their technology, if the technology permits. Obviously there is a test bench, and there will be some test results to support my claim. Okay, so these are some major areas of concern which are solved by the researchers, by the application engineers nowadays, so that now at this time, electrical vehicle market booms, and in upcoming 10 to 15 years, the market projection is exponential growth. So I'll show that thing also. So I'll tell some basic difference. So on my left hand side, it is IC engine powertrain. On my right hand side, it is electric vehicle powertrain. So what are the basic difference? Basic difference, if I talk about the cons of the IC vehicle, so it is that less efficient and highly pollutant. So yeah, obviously you can talk to me like that, that BS6 engines is there, which are less pollutant, but overall it is highly pollutant with respect to the EV powertrain. So basically pros, if I talk about the EV powertrain, and EV powertrain means basically the meaning of the powertrain is that the motor control unit, which basically able to drive the vehicle. So here the 50 to 65% efficient engines are there, which are much more efficient than IC engine. and it is less pollutant, obviously, for its reasons. So, but what are the pros in the IC engine, or advantages? So the advantages are there. So basically, readily available fuel. So if you go to ride, it's weekend, and if you want to go to some ride to Simla from Delhi, so you need charging station. Not charging station, means for refueling station, for refueling purpose. And one, full your tank, so you can go up to Simla, or means larger distance in one go. No need to charge again. So here comes the major challenges in electric vehicle. One is range. Whenever I'll go to some showroom, I will not go into the the inside technology, because I didn't, as a common man, I do not have the idea. I have the idea what is the mileage of the vehicle, and how quickly it can be charged, and is it cost effective or not. So there are two kind of cost. One is that capital cost, another one is operating cost. So capital cost in nowadays, if you see the electric vehicle cost, it is bit much higher, but with the technology development, it will come to closer to IC engine, and maybe lower than IC engine. Also, the operating cost, definitely in India, it is lower. That I can tell you, because of the prices, fuel prices are going high in exponential manner. So that is the thing. But we need to develop a very means it is right now very few charging stations are available if you compare it with the refueling station. So so you need to have the last mile connectivity. So everywhere you need to have some electric vehicle charging station, first thing. And second thing is that, yeah, obviously long charging time is there. So so basically you have to reduce the charging time. So obviously in the previous slide I have explained so how you can reduce the charging time with the advanced battery technology. So these are the some of the major research objectives in the electric vehicle side. So I am talking about the electric vehicle boundary. I am not talking about the grid from where you are taking the power. Obviously, some of the electrical persons, they might think, okay, there are some research objectives coming from the grid. If you will take so much power at a time, so what will happen to the grid and other issues? So I am not going to that portion. Today's my boundary will be the electric vehicle powertrain and EV. So I am not going to that grid portion. Okay, so I am limited to this, and I'll tell some of the research objectives or the problem statement. Rather than I'll tell you the problem statement, which is driving through the industry, and maybe academia can also join in coming days, like what happens in the foreign. So this would be some of the research objectives or the challenges which is faced by the industry, and that can be solved by the academia because they have the knowledge pool also. So that can be solved. So these are the very important topics. So now why I am talking, so obviously there should be some business perspective also, and whoever is interested to do some startup, maybe you are interested for some funding from DST and other things, definitely you have to defend your thought. So for that, obviously I have to present some data which would be from some good websites like Bloomberg. So I have taken some data from Bloomberg, and you can see that it is the exponential growth, and up to 2040 they have predicted, and they have said that 35% of the all new vehicles would be your electric vehicles. So so this is some before COVID graph I haven't updated this graph. So this is the prediction on my right hand side for European market, and you can see that Volkswagen, Daimler, BMW, Hyundai, Renault, Volvo, everyone is there in the race of the electric vehicle market. So, and now you are all aware that even Tata in Indian market, you are having Tata also, and Tata is having, I'll just share one thing. Even in the newspaper also you'll find Tata is having right now very aggressive electric vehicle market strategy. Definitely they are having their own electric vehicle public transport. and it is running smoothly, operating in the major cities like Delhi, Kolkata, Hyderabad, etc. But the other thing is that Tata is very aggressive in Indian market. They want to launch at least 10 variants of the electric vehicle, which would be much more cost effective for India. So, much more things are lining up for upcoming 5 to 10 years for India in electric vehicle market segment, that I can, assure you. So basically, this is a good time to jump into this area. And yeah, it would be there in India at least for upcoming 20 to 30 years. So yeah, definitely who are interested for startups and anything. So there might be two areas. One is that charging station business. So you can give customer the last mile of connectivity by allocating your charging stations. And yeah, there might be some of the advantage and disadvantage of your proposed charging station, but with the knowledge you can always encounter the problems. The second thing is that obviously electric vehicle, it is going to develop, and from its pros and cons, from the and feedback from the customer, it will evolve itself with the 1 to 2 decades. So that that kind of thing will happen generally with the market. So these are the basic business behind my thought process. So now if you talk about India, yeah, government, though I am not a political person, but I can say that yeah, government is interested to move towards this green revolution, what I can say. So basically the Nitin Gadkari ji, so our road transport and highway minister, he has already said, I just quote a few lines, only one line, but yeah, you can go through the total documentation, what he has said. So basically, there is a push from the government, from government for that EV segment. So now in the current budget itself, there is a push for battery swapping station also, so that they want to reduce the charging time, so that you can go to some battery station, you can exchange the battery, you can just give them the your what I can say, that 0% SOC battery, and you can take the fully loaded battery, and you can just exchange, and you can again drive. But the problem with that is that there are several battery manufacturers, and none of the hardware as well as software interfaces are bound by some standards that it need to be happen like this. Yeah, there are some standards there, but the standards are defined in a boundary in the functionality point of view. There are no such boundaries that, like type C charger in your mobile, like that chargers are present, but battery kind of thing there right now it is not there. So battery swapping station, it might take some time, though government is giving push. Okay, so basically here this slide is very important for your basic understanding. So I'll just give you a typical electric vehicle architecture. So here, this is some, what are the major things. So the main costly components, these are battery and battery management system. So as I already told, battery is the hardware component itself, and battery management system is the software which ensures the safety of the battery. What is the meaning of that safety? Suppose the battery temperature reaches 80 degrees Celsius. So battery BMS ensures that battery should not turn on even if we give command. And the same thing, it would show to the monitor or your some kind of display, monitor or display, that it will show the fault, that high temperature reached in the battery, high temperature reached, and some kind of fault is demonstrated. So that ensures, okay, high temperature fault. Another thing ensures that if SOC difference between the battery packs or between the cell is too high, or the difference is too low, so that is not low, too high, then also we have to stop. Otherwise, the battery balancing would not happen. So this kind of things would be ensured by BMS. So this is the number one thing. Number two is the inverter motor set for drivetrain, including motor control unit. The motor control unit do the same thing. It does the same thing. What it does basically, yeah, obviously you need some inverter because battery runs on DC. So you need, but most of the motors in today's industry, they run on AC. So mostly industry are doing with PMSM motors, permanent magnet synchronous motors. Also they are using induction motors, but most of these two motors basically they are running through AC. So this might be 3-phase, this might be 6-phase, this might be 9-phase induction motor or your permanent magnet motors. So there are some typical advantages for permanent magnet motors in case of your electric vehicle powertrain. So that is space and maintenance. These kind of things are advantageous. So you need the inverter unit, and definitely how you can define the control flow and the control flow of the inverter, how it is being operated. And definitely you need to control the duty cycle of the inverter in order to set the motor speed. As you all have studied the electric drives section, I think on 4th year might be so, and anybody is teaching, so they might know that yeah, definitely you need to add up PWM switching, and you have to do the PWM switching optimally to ensure the safety as well as the proper speed versus torque characteristics of the motor for your application. So that kind of control would be done by the MCU or motor controller unit. So not only that, also safety point of view, suppose you have one 3-phase inverter, in one leg there would be 2 MOSFETs or 2 IGBTs. So these 2 might get short circuited, these 2 might get overheated. So that kind of what will happen? Suppose this is very dangerous and very critical scenario. You just think of it. Obviously industry always have its kind of precaution, but you just think, so you are driving in a hilly region and your MOSFET gets burned. So definitely you will not get any output at the motor, and you cannot drive your vehicle. Suddenly you lose all the acceleration. So you need to be very critical whenever you are designing your inverter. You need to give all kind of protection. You need to give every safety in your mind. Definitely there are some standards. So you have to keep all the standards in your mind, and you cannot skip any steps for development. So you have to go through the whole steps. So these are some basic things you have to go through. So this is the your operation and the responsibility of the motor control unit. So basically there are you have already used a DSpace or Texas Instrument controller or STM32 controller. This kind of controllers are basically used for your BMS or for your MCU application for the sake of the clarity. So inside the controller, you have to dump your own code and or flash your own code, and not your own code, might be if you buy from any manufacturer, they can give you readily available because they will sell the whole unit to you, but that will be much more costly. If you build by yourself, it will be cheap. These are the basic difference cost wise. So obviously the third important thing is that charger. So definitely there are 2 concepts, fast charging and slow charging. Slow charging is your onboard charging. So, and fast charging, definitely how fast you can charge on the based of the capability of the battery and based on the your grid side or charging station side, what is the capability to throw the power, maximum amount of power it can deliver. So these are the chargers. Number 4 is the DC-DC converters. So DC-DC converters, basically it may be stepped up converter or step down converter. It is based on your voltage and power level of the vehicle. And the fifth important thing is the ECU, or electronic control unit. Basically, it is the master or supervisory controller which controls or which ensures to control to bound all the unit present over here. So what are the units? Basically, there are chassis and body. So what do you mean by chassis? I will tell you some of the functionalities like accelerator pedal, you are pressing, brake, gear, brake pressure, body suspension. These functionalities are all related to chassis and body. So these are the chassis and body, some functionalities. So definitely there would be a issue related to the chassis also. There would be some air compressor which is needed for your pressure generation, for your brake pressure. There would be some steering pump which will ensure the your steering is hard or soft based on your steering pump. Yeah, definitely passenger comfort would be done by air conditioner in recommended practice. There would be a display unit which would show you the current status, that right now what is the gear you can drive, or you are in reverse mode or you are in neutral mode, you can drive how many kilometers, whatever you can show that based on your customer requirement you can show here. And the next thing is that you can design according to your electrical architecture requirement, that is low voltage junction box or low voltage distribution box. Basically, there are some units or the controllers, basically, these are running with 12 volt, 24 volt, or 32 volt or 48 volt. These are low voltage. So basically you have to create a distribution where there might be some of the relays you need to operate which are acting on 24 volt. So these are the part of the low voltage distribution box. And definitely there is a need of the high voltage distribution box based on your architecture. So meaning, so there would be some contactors, some solid state relays if needed. So these are the part of the high voltage distribution box. So there should be some leakage monitoring also. This leakage means it is not water leakage, it is current leakage monitoring. So if so what is the meaning of leakage? Basically, if positive and negative plate of the DC shorts, what will happen? So basically one concept that is called short circuiting, another concept is called leakage. So these two are different things. So there is a if your positive path is connected to the ground of the vehicle, and ground of the vehicle is considered as your chassis ground, that is obviously the chassis ground is connected to the chassis, and it is the chassis body, and the other thing is that battery negative should be connected to it. So that is the reference point for your low voltage. So whenever you are designing, that is the reference for reference voltage or reference ground for designing your low voltage system or 24 volt system. So definitely there is some high voltage system. So if the high voltage system shorts to there, so what will happen? There is a chance of damage of that component or even to the passenger. So to ensure the safety, here you have to put some leakage sensing also, and that is very much important. So according to your safety standards, there are several safety standards in automotive industry, and it is not only automotive industry. As an electrical engineer, these safety standards, I can ensure you that these safety standards are designed explicitly for automotive, but it has been taken from IEC standards. So IEC standards basically are related to electrical engineers. So definitely it is a concept of electrical engineering only. So you have to go through these standards, and it is very important in industry, in your general practice, because in academia, I know that people generally don't go through the standards, but it is a very good practice and we should do it. And we should refer standards anywhere you are doing your research, your work, and this kind of standards would give you, means it will give you the confidence, because whenever you are suppose anybody is doing the power quality things and harmonic mitigation things, and they would say that okay, my harmonic should be less than 5%, but who said that? I am not saying it, or anybody not saying it. So it is saying by IEEE 519 standard. So who is saying this standard? You need to clearly mention it. so that you are confident that your result is getting validated. Okay, so you need to be that within that boundary. So here high voltage distribution box is another important thing. So basically how to control the relay, how to control the high voltage contactors, what are the different sensors you are putting, what are the different the safety mechanisms you are putting inside the vehicle that would ensure your safety, and most probably that would ensure that nothing means nothing like happened in Ola. So yeah, definitely there would be some incident, because even IC engine also they caught fire in, if you remember, in Nano it caught fire. So definitely there would be some incidents, but we need to ensure safety whenever we are designing some of the vehicles, because it is a era for electrical engineers, as electric vehicle is in market. So you can explore this market in different way. So you must design this kind of electrical architecture. You are able to, even this kind of architecture you can adopt for your campus, in campus vehicle also. And you can I can say that it will be very cost effective and very good for your BTech students to apply their knowledge. Yeah, definitely you can say, okay, for BTech students it is a project, but what would happen if you have a ready-made system in place in your campus? So that might be made by the BTech students, but for MTech students, he has the whole architecture or whole scenery in front of him. So he might do some of the some work in DC-DC converter, but everybody is doing work on DC-DC. What is the application of that converter, where it should get applied? Nobody can answer these things. So if he can answer this thing, definitely he knows his literature review in critical manner. Okay, that is the reason why I am doing this kind of research. Okay, so he would get some answers. The same applies for PhD thesis also. So the same thing. And the last thing I would mention, it is not necessary, but I would mention that one of the good features in coming days or right now is IoT. So for you can track your vehicle from sitting, the vehicle is running on in Calcutta, and you are just seeing all on screen or monitoring it from Pune. So basically this is the tracking activity, how the vehicle is performing, or is there any problems. So basically it is sharing the data on regular interval. So what is the DC-DC current, voltage, battery voltage, is it now running with smoothly, and is cooling is proper? This kind of data are shared on regular interval. And what I am telling you, these are readily available data, and it is sharing on the cloud. And from the cloud you can obviously download, and you can examine, and you can check that if the vehicle is meeting its behavior. And whenever I am telling you the behavior, it is not like that you have developed, you have delivered, your work is done. Not like that, because all the vehicles running in today's market are new. We don't know how it would behave after 10 years of the operation down the line. So you need to capture all the data, like vaccine data they are capturing. After COVID vaccine data, they are capturing after 1 year how much antibody is present. Like the same thing, it is the new thing. So you have to capture the data to prove your analysis, and after 10 years down the line you would match up all the data with the practical examples. And then you can say, okay, my battery is really cost effective, or my system is really cost effective, like this. So you have bought a car and it should go up to 25 to 30 years, because you don't want to spend so much rupees on every 5 years you want to change your cars. So that is the main thing. So there is the importance of IoT for tracking your vehicle and sharing the data on regular interval. So already what I have developed. Oh, another major thing I want to share, that there are communication mediums in between all the modules, and mostly on the vehicle side it is communicated with a protocol called CAN. So control area network. So basically it is a controller. So basically I want to speak to you and I am speaking with a language called English. It is the same kind of thing. So it is a CAN network with whom, with this medium, I can talk to the vehicle charging. I can talk to battery maker. I, as a supervisory control unit, I can talk to anybody I want. So this is the typical architecture of the, if you want to develop an electrical vehicle. So these are some of the major components, whatever I have discussed already. So here it is listed actually. So next, I'll tell you. So these are the torque versus speed characteristics. So why PMSM is the mostly used in industry? Because if you want to, basic example, if you want to start your vehicle, means it is in standstill. And if you want to run your vehicle or run the motor, you need maximum amount of torque to, for against your flow. So you have to apply maximum amount of torque so that you can go into forward direction or reverse direction. So at the starting, torque should be very high. Okay, after that, as the speed increases, your torque requirement goes down. The same concept here. If you see the PMSM motor curve, so this is the same kind of curve it follows. Though somewhere, if you see the DC series motor and induction motor relates its, but PMSM is closely suitable with the operation. So this is one of the thing. So from the torque versus, so whenever you are reading something in the GK Dubey book and or any book of the electric vehicle, or not electric vehicle, the electric drive. So whenever you are checking some graph, so where it is applicable, you should question it. Why it is so and where it is applicable, why it is applicable. You should get to know these things. So because we read something, but we didn't apply it whenever it is coming. But if I later ask, you can say, oh, this one I know. So we know everything, but we have to apply this knowledge. So yeah, definitely I'll just go through, cover up the charging first. So there are some EV charging standards. So there are level 1, level 2, and DC fast charging. Then this kind of charging is there. So yeah, definitely worldwide, there are some charging standards followed by worldwide. You cannot, wake up from your dream and you cannot, build any charger. So you have to follow some protocol all over the world. So basically Chinese in China, they are following GB/T protocol. So if you go to China and they are, Hong Kong and other territories, their GB/T is the only protocol they are following. And these are the some standard specification. So you have to follow it. So, it is not a very low voltage where the electric vehicle is operating. You can see it is 1.5 kV, kilovolt, and 600 ampere is the maximum rating in which you can operate. So in CHAdeMO also, you can see CHAdeMO is the, CHAdeMO is the Japanese protocol, and I have worked with Japanese people, and they also called tea to the chai. So basically, whenever you are, drinking the sip of tea, basically the electric vehicle charges itself. So from there, CHAdeMO comes into picture, and it becomes the standardized, and now globally it has been used. So it is the story behind the CHAdeMO, and CCS also, in India and your US. CCS is used, and Tesla, definitely they have developed their own standard, and I think they are using that kind of charger for charging standard for them. But what I here try to say here, all you can see that most of the communication medium is going through the CAN. Okay, this is the number one thing. Okay, another one thing, that the 12-volt power supply is needed. So basically 12 volt means low voltage power supply is needed, which is basically enables the communication in between charging station and vehicle. So that makes your vehicle and your charging station intelligent. So if anything goes wrong in between them, they would stop charging. So definitely some kind of protection would be there. Another one thing is that wherever it is available, CHAdeMO is available globally. GB/T in India is available. EU means your European country, and US, they are following CCS. And if you see that these standards from where this GB by T and CHAdeMO and CCS is coming, all are coming from IEC standard or IEEE standard or SAE standards. So as you, as an electrical engineer, most of you are electrical engineers, you can see that all are coming from IEC standards. So I would recommend you, so in whichever area you are working, it is not should be electric vehicle, in whichever area you are working, you should definitely look on the standard, look upon the standard. You can claim for claiming your result is correct or inside the boundary or not. So that would give the reviewer that much confidence. Okay, he knows about standards and he is working on it, and he are doing, because even reviewers sometimes don't know and they are just blindly following. Okay, this should not happen. But if you give some kind of standards, and if you give according to the standard, then reviewer also thinks, okay, I didn't know this standard, so he has accepted this, and okay, this might be true. So this kind of validation should come from standard. And also from the standards, you would get to know many things that you are not knowing about your area of specialization right now. So here you can see that liquid cooled cable are under development. Actually, it is quite old document. So liquid cooling is also available in some of the protocols. So basically, how the charging plugs have been developed. So most of the charging plugs, they are communicated either by CAN or by PLC. But PLC is basically costly. So basically, normally what is happening, all are using CAN. And you can see that CHAdeMO in Japan, they are following, and GB by T in China, they are following. And this kind of plugs are used, and it ensures safety. Suppose you are charging and you want to you are pulling the plug out from the vehicle, but it cannot happen. It could not happen because of some obvious reason. It could not happen. So what would happen actually? So safety is properly ensures. Okay, just give me 1 minute. So pardon. Okay, sorry for interruption. So so these are the basically charging standards, and these are DC charging system. Whatever I am showing here, there might be from AC to DC charging stations also available, and that kind of converter is installed in the charging station or might be installed in the vehicle. So, but there are different configurations. So the motor control technique, how it says, means in the your IC engine powertrain, whatever you are doing, you are basically pressing the accelerator pedal, and your vehicle is getting driven by that functionality of the IC engine. But what happens in the electric vehicle, or how it is getting controlled, the same kind of characteristics is getting controlled. See here what is happening. Suppose I am ECU or the master controller. So as a master controller, what I am seeing, that if the person, so basically if I'll do the programming, how I will write. So if your one person presses accelerator pedal and brake is not pressed, then what I am thinking, the person wants acceleration. Okay, so this is one thing. So at that time, I'll give the command to my inverter, okay, just increase the duty cycle or the PWM pulses, so that the motor should run in advanced manner, or from 500 rpm to 2000 rpm, so that I can get accelerated. So at that time, from the battery pack, high power is getting driven to electrical motors, and accordingly the same torque is applied, and the output of the your torque is getting driven as speed, and it is translated into the your speed, and it is getting driven. So basically this is kind of thing you have to generate. So this is called control algorithm. Basic example, if the brake is pressed, you can even regenerate from here. So basically there is a you have all know the 4-quadrant operation. So 4-quadrant operation of the electric motors will apply here. The knowledge, whatever you have read, that would apply here. So here, one of the things that is get applied here, whenever the driver presses brake, so whatever energy is generating in the, your brake mechanism, that would be getting fed to the battery, and that will recharge the battery on the go. So basically this will improve your efficiency. Okay, so this kind of technology and this kind of control algorithm you can obviously develop. And yeah, obviously I have given you some of the job opportunities for engineers. So basically there are electrical engineers needed for electrical architecture design, developer are needed for control algorithm development, and obviously there is a need for system engineering also, who would see the systems overall, how the system will behave, how the system will depict and everything. So the third thing is the power electronic engineer, who are needed for converter designing and analysis. That might be your charger, that might be your battery management system, definitely for your programming and coding. The electronic engineers are needed, or computer science engineers are needed, and design engineers for mechanical engineering background are needed. So here I am not considering the fuel cell here. I am just giving you the demo for electric vehicle. So I'm not talking about the fuel cell. Yeah, definitely nowadays fuel cell is also getting its push, but I'm here only concentrating on the electric vehicle. Okay, so so here I am just giving you the generalized electrical architecture. So here the onboard charger you can see on the top. So this is isolated. This should be isolated, and isolation is very much important. Because in laboratory we are developing buck converter or boost converter, but in industry or in safety standard wise, it should not be used. So it should be isolated for our kind of application, and it should have its own issue. So everywhere whatever you are using, so motor is having its own issue, battery pack is having its own issue. So everywhere issue are there, and these issues, all the issues are communicating to the master issue through some communication medium. So here the communication medium is CAN. Okay, so whatever I am showing, and I have shown that low voltage supply. So basically you have high voltage system. From high voltage system you have high voltage contactor. By operating this contactor, you are using that step down DC-DC converter, and that's how you are charging your low voltage system. Basically there would be one 24-volt battery or 12-volt battery in your vehicle, and you are charging that battery with this kind of technology. So these are the some of the technologies available, and here the red and black broad line is the high power line, and this is how the power flow happens in normal direction. So there are some high voltage contactors definitely needed, and some of the safety fuses and everything you have to take care whenever you are designing. So the next thing is that whenever the points to remember while designing EA, if I as an electrical engineer you are just came here, I would definitely love to ask, so what are the points you will consider whenever you are designing your electrical architecture? So the first point is that the power flow, analysis of the power flow for each and every possible condition. So what are the conditions? I can say, so these are some basic requirements. So vehicle is in stop condition, and vehicle is moving in the forward direction. Vehicle is moving but in regeneration. Vehicle is in stop, and charging is in process. So these are the some of the areas where you have to go through the power flow calculation, how the power flow is happening from battery to motor or from motor to battery. If you are considering fuel cell here, so you have to balance it in between fuel cell, in between battery, in between your motor. I am not going into the fuel cell today, but any other day I'll go. But the second point is short circuit analysis. In power system, every power system protection everybody has done. I think the short circuit analysis, you have to do that thing with the help of software, with the help of mathematical formulation, everything. So the third point is the very important standards you have to go through: IEC, SAE, any standards related to your wiring design. So here you might say, okay, I am not going through the insulation standards or something. Yeah, definitely all comes under IEC. And the fourth point is very important, that is failure mode analysis. If this fail happens, how you will overcome this scenario. Okay, so this is the fourth thing. And fifth thing is that vehicle level standards. So vehicle level standards like R107, R100, this kind of standards are there. There are companies like TUV are there, so to monitorize and to give you the permission to drive the vehicle in the country. So they have their own standards and you have to comply that. Yeah, definitely if you follow the IEC and SAE standards, they are the subpart of the R100 is a subpart of the IEC standard. So definitely whenever it is a subpart, so definitely you are covering all the scenario, all the requirements of the system. Okay, so if I talk about that second job opportunity, that is developer or control algorithm development. So here, why it is needed? Because the Boeing 787, the one of the largest flight, so that is having 80 lakhs lines of coding or 8 million lines of coding. But if you see the Chevrolet Volt, so the modern day car, so it is having the 40 million lines of coding. So much more complex coding is required nowadays for your vehicle or car. So that's why the software engineer, the developer, the electrical engineers are coming into picture, who can see the system development or system behavior. So here basically your customer might say, okay, I need to integrate all these functionalities, along with I need to be cheaper, I need to be innovate it easier, and the development cost might be minimum. These are some of the things which I need to take care. So for these things, yeah, definitely this is a challenge for your development process. So basically if you come to the industry, so I'll just give you a brief idea about the industry, how industry works. Basically, if I am Tata and I am giving some project to some company, so how it will be? Okay, so first you are going to the customer, and customer would give you so customer will give you the thing that, okay, I need to build this vehicle which would ramp up from 0 to 100 kmph in 2 seconds of time. They would tell this thing and they would say that, okay, you need to build a vehicle which would ensure all related standard safety process. This is your requirement. So this is called the requirement. So what, as an engineer or as an professor or an electrical, as you all are professor, but you are engineer at first. So as an engineer, you should first develop the concept. Okay, from this requirement, one line requirement, you have to go through the system level of requirement. Okay, so this is called V cycle. So you first go through the system level requirement. Okay, what are the systems I need to carry forward his proposal? So you first decide the systems, you first jot down the requirements. From there, your system design requirement, your architecture requirement. It might be electrical, it might be software architecture design, and after that, detailed design and detailed implementation are required, both as in hardware, both as in software. Finally, the integration, testing and validation and verification. These things are required. Definitely, it is not so simple. There are several, small steps inside these big steps. And finally, the operation and maintenance. So this is any project in industry is going through this cycle, any development project. So I am correcting, any development project is going through this cycle. So you can just search V cycle in website and you can see how the end-to-end product development process happens. So from scratch to the homologation of the product. So you can be very sure from here to here I can do with the process, this kind of process application. So yeah, basically if I talk about your software, so the software point of view also, if means we are using MATLAB nowadays for its simplicity and its it can be used in controller. Also not only simplicity. Basically, if you debug a code written in C, it might took actually 1 month to debug if any fault is there. So to clear all the faults, but in MATLAB, as graphical representation is there, also the documentation is much more simpler. So here you can say that in MATLAB it is very easy to design, very easy to understand, and very easy to debug your process. So basically there is a system specification, high level design would be there, and then only the low level design. Low level means subsystem design would be there. So from the subsystem implementation, there you have to go through the testing and you have to complete your testing. So first point would be your requirement. Second point would be your development. Third point would be your integration and testing. So these are the basic steps. Sorry. So I will just just keep for now. But I think so. Basically, there are some advantages of the model-based design. So MATLAB-based designs are called model-based design. So you can search on the internet and you can get some of the pros and cons. So it is a common design environment, and link design directly to the requirement. So from the requirement you can directly link it, and you can identify and correct errors continuously by integrating testing and design, what I already have said. And you can refine algorithms through the multi-domain simulation. Yeah, you can definitely do the robotics with mechanical portion, with electrical, with computer science, everything you can go through the one algorithm, and you can do the multi-domain simulation, and you can automatic code generation is supported here, and also documentation is a important part. So, and develop and the reuse of the test case. So whatever test case you are generating, you have to give it a pass or fail. So basically this is the workflow. I am just skipping. So these things I'm skipping. Okay. So this is very important. Whenever, whenever you are, you are using MATLAB, so you have to buy some toolboxes. If you want to buy the whole MATLAB, it will cost you a lot of money. So basically you have to optimize that thing also, right? So you are not using the whole MATLAB, because everybody is using MATLAB, but you never use the whole lot of skill sets of MATLAB. You need some of the things. So just control VER in your window, MATLAB window, and you can see what are the different things are installed in your MATLAB. So basically applications are installed. So I need only 5. So basically I have done my cost cutting. So my manager is happy. So like that you have to do. So whenever you are doing, so you can go to your supervisor. I can say, okay, sir or ma'am, I need only these 5 things. So not a very much costly things. So yeah, you need Simulink coder, you need Stateflow, you need embedded coder and Simulink. These are the all 3 things, 4 things you need as a toolbox in your MATLAB. So I'll skip these things. Okay, so here I have shown the conventional approach and the model-based design or MATLAB-based design approach. So here you can definitely see that in model-based approach, basically the system analysis is first there, and after that, yeah, concept evaluation phase is there. Basically, what happens if you follow the first kind of conventional approach? At the first, you need some test bench or hardware, but in the MATLAB, you are as an engineer, you can design any system, right? With with equation, it may be non-linear equation, it might be linear equation, but with these equations, you can definitely design the system. Even if it is a car, basically what is happening, you are giving torque command and it will give you the speed output, and the relation between torque and speed. So you can definitely design the plant model, and it is called plant. And the controller or control system which you are doing, that is called your control system or controller, okay, or control model. So this you can design separately. So plant model and control model, you have to integrate it integrate it in MATLAB only, and you can show that okay, in simulation it is working fine. And these things in any project, you as an electrical engineer are doing this thing, but you didn't know the proper process. So you must be aware of this kind of processes nowadays, because nowadays and in the upcoming days, engineering would be industry driven. So because you have to get placed, right, in some of the and there is a huge market for electrical engineers, and so you have to be get placed. So you need to have this kind of applications and this kind of knowledge. So this is called MIL, model in loop. After that, you can go to SIL, software in loop. So what is basically software in loop? So you can just, go to your control model, and you can just, generate its equivalent C code. And the C code would be now integrating with the plant model. And plant model, as I already told, it is a multi-domain. Plant model can be in mechanical domain also. If you have the toolboxes, cost permit, then you can integrate it, and it is called the software loop testing. Okay, after that only you need the laboratory to examine it, like DSpace, like your controller, to implement the code inside that controller, and what is happening. Okay, and finally the vehicle in loop. And in your laboratory, it might be your HIL, it might be your, the active power filter or your inverter, whatever you are building in your laboratory. So that might be your area of work. So you must follow these things, and I can guarantee you your process would be much more smoother. So you can follow. So this is some approach I have given. So definitely I have shown some of the, in pictorial representation only. So you can go through later. So some of the differences I have gone through. So yeah, so this software architecture part and other parts, I think already time is over. So I'll cover some later days. So the state flow, this I will skip for now. So yeah, so I want to just ensure that these are some safety standards of software, for software hardware. So basically there is a functional safety for electrical safety standards, or PES safety related standard, that is IEC 61508. This is the mother of all standard. Okay, from here for road vehicles, ISO 26262 is defined. Okay, so ISO 262 is definitely designed for vehicles, but it is a subset of IEC 61508. So you now you know the standard. You can definitely go through the standard, and you can just see that if what are the things are relatable to your work, because it is a functional safety for your electrical components only. Yeah, so I'm not talking about some other domain or some other things. You should know your own things. So this is the main thing I want to convey here. So basically this is a ISO 262 is a European Union standard, safety related standard, so for electrical system in the passenger cars. So now it has been expanding to the trucks and motorcycles from 2018, and it addresses basically the possible hazards caused by the malfunction within and between electrical safety related critical system. So the same thing, I'll give an example like Ola. Whatever happens in Ola, so that might happen anywhere. So for that, this is a 26262. This kind of standards are there. So you should not skip before launching your vehicle. You should do all the analysis properly before launching your vehicle, so that it should be as compliant, SLA, some kind of compliance are there. So it should be safe. What I can say, it should be safe for passengers, because our main motto is to give safe operation to the passengers, because they are the end users. So evolved, these are the evolved from IEC 61508, what I have shown previously. So for MATLAB code, there is a standard called MAP, and there is a for C, for equivalent C code generation, there is a standard called MISRA C, and these things are already available in MATLAB. Whatever code you are generating in MATLAB, you please check it, and after checking, just check, okay, how much percentage it is having the code coverage, or what are the different things we shouldn't use. Everything is mentioned over there. So you should give a try to the map and Mr. C whenever next time you are building your code in MATLAB or in C. And thanks. I think that's all for today's presentation. So these are my contact if anybody wants to contact. Yeah, or else you can get my contact from professor. So yeah, so these are my Google Scholar profile or LinkedIn profile. So thanks for patience listening.
Thank you so much, sir. So I am sure the students have learned quite a few things about electric vehicles and the challenges, and some of them have also posted some questions. So if we can take a few questions from the audience.
Sure.
I think we should take only one or two, as
Okay.
already Dr. Ray has given a lot of time to us.
Okay.
Sir.
Yeah.
So one question is from Dr. Sinha, that what are the challenges when it comes to the standards? I mean, how do we decide a single standard?
No. Coming to one standard. So basically there is not one standard is present. Basically ISO 262 is a huge standard book. So this is a process defined by the standard. And whenever you are going through the standards for hardware, definitely you have to follow the other standards also. And from one standards, it will lead to another standard. And from there, it will lead to another standard. So it is not that one book you will follow. It is like your textbook, another reference book, or one paper to another research paper you have to follow. So like that, you have to dug it.
Also, one question from Ankit, that what about what is the particular region where electrical engineers can manage even without knowledge of coding?
Yeah, so I can clearly, frankly telling you that, yeah, I don't have that much, C language coding skill. If you ask me, still I am working on the electric vehicle industry. That I can tell. So definitely you have a lot of scope. Yeah, so it is not like that the coding is the only thing you have to learn. So basically system understanding, and in whichever area you are working, the understanding of the system is the basic requirement of any job role. Coding is the not only thing, because whoever is coding, they don't have the knowledge of the system. You will give the knowledge to the system, knowledge of the system. I'll give him the knowledge and they will just do the coding. And believe me, in MATLAB, coding is not so difficult. You can integrate your own system. You can develop your own system, and definitely, yeah, I am a live example. So yeah.
Okay, one last question from Anita, that what is the idea about replacing PMSM with synchronous reluctance motor? SRM.
Yeah, so okay, so synchronous system, yeah, so I haven't worked with this one, the synchronous reluctance motor right now, so I cannot give you the brief idea for replacing this one because I don't have that much of evidence right now with me. Yeah, definitely I'll go through this one question. Might be the next time I'll give the answer, or I'll try to give the answer. Okay.
Okay, thank you so much, sir. So I think Dr. HP Singh, can you please thank the speaker?
So Dr. Ray, on behalf of Amity University, our founder president, sir, our chancellor, sir, and our vice chancellor, Dr. Balwinder Shukla, I would like to thank you for delivering this knowledgeable lecture. And we all know that what is the importance of electrical vehicles, and perhaps this was the best lecture I have seen in the previous 1 or 2 months that we are listening to different speakers. So you have covered a lot of things regarding electrical vehicles, and this was very important question by students. Without coding, how can you do? And you are the best example for that. That you can learn a lot, and there are so many things. EVs are interdisciplinary things, not only for coding, not only for electrical engineer, not only for mechanical engineers. So there is a lot of scope for the students to do in this area. They can do their job, or they can go to the research also for PG students, that they can opt for this area and they can do lot of things in this field. So with that, I would like again to thank you. Thanks a lot, sir. And we hope we will meet soon.
Sure. So have a great day ahead to you guys. Happy weekend to all. Enjoy, stay healthy. Yeah.
Thank you, sir. Thank you a lot. Thanks a lot.
Bye.
Thank you. Bye.
So we can end this session. I'm meeting host.